In my last video, I explained how Bernoulli's equation can be used to relate 2 points within a laminar fluid. Areas where the fluid is moving with a high velocity are low pressure, and areas where the fluid is moving with a low velocity are higher pressure. In this video, I wanted to go over a simple example problem. Suppose you're given the following problem where you're told that water is pumped through the basement pipes of a house at a velocity of 2 meters per second through pipes that are 5.7 centimeters in diameter. This water is at a pressure of 3.3 atmospheres. Knowing this information, you're asked to find the velocity and pressure of the water on the second floor of the house if those pipes are 3.5 centimeters in diameter and 6 meters above the pipes in the basement. Solving this problem will involve using both the continuity equation and Bernoulli's equation. To start, we'll need to use the continuity equation to find the velocity of the water on the second floor. The continuity equation tells us that the cross-sectional area of the basement pipes multiplied by the velocity through them is equal to the cross-sectional area of the pipes on the second floor multiplied by the velocity through them. Here we'll let the subscript 1 represent the basement and the subscript 2 represent the second floor. Rearranging the equation, we can see that V2 is equal to A1 multiplied by V1 divided by A2. We can then just plug in the information that we're given. We know that the cross-sectional area of a pipe is equal to pi multiplied by the radius squared. We're given the diameter of each pipe in centimeters, so we can determine that the radius of the basement pipe is equal to 0.0285 meters, and the radius of the second floor pipe is equal to 0.0175 meters. Notice that the pi terms cancel out, so it's just the square of the radius of the basement pipe multiplied by the velocity of the fluid within it, divided by the square of the radius of the second floor pipe. Solving the equation, we can find that the velocity of the water through the second floor pipe is equal to 5.3 meters per second. Using this information, we can now use Bernoulli's equation to find the pressure in the second floor pipe. This is just simply a matter of plugging the correct values into the equation. Note that the density of water is equal to 1 times 10 to the 3 kilograms per meter cubed. In addition, it's important to know that 1 atmosphere of pressure is equal to approximately 1 times 10 to the 5 pascals, or newtons per meter squared. We can first simplify each term, and then finally solve the equation to find that P2, or the pressure in the second floor pipe, is equal to 2.59 times 10 to the 5 newtons per meter squared. We can then multiply by the conversion factor mentioned before to find that the pressure is equal to approximately 2.56 atmospheres. I hope that this video was helpful in demonstrating how you can use Bernoulli's equation to solve fluids problems. You can see how often you'll have to use other fluids equations, such as the continuity equation, to solve problems like these. If you still have any questions on this topic, feel free to comment below and I'll do my best to answer them. If you found this video helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.